Today's lesson in 7-2-1 proportionality is lesson number 1. I can determine proportional relationships. On your notes, please add your name and today's date, and then let's get started. First, we have to define what is a proportional relationship. Proportional relationship is a relationship between two variables where the ratios are equivalent. Ratios are equivalent. And remember, when we talk about equivalency, it means equal. So the ratios are equal. We also can think of this as the same constant rate we're looking for. Looking for the same constant rate. That's another thing to double check for when we're thinking proportional relationships. When we're looking at proportionality, we actually have two different ways to test for this, which we'll talk about. When thinking of the two ways that we have, the first way that we can do this is to find the unit rate and then determine if they're the same. The second way we have is to cross multiply. So remember, when we cross multiply, we multiply on that diagonal. And we set the first diagonal in green. Does it equal the second diagonal in orange when we're multiplying? So looking at this example, it says, in the back of a recipe book, a diagram provides easy conversions to use while cooking. The number of cups and how many ounces. So the first way is to see if they have that same unit rate. So when we're finding unit rates, if we think about tables, we have X and Y in our table. To find a unit rate, we're always going to take Y divided by X. This is something we'll talk about more in upcoming lessons, but it's super important to know it's always Y on top. And so when we're thinking about this, Y divided by X, we can look at any of these rates. And I'm going to look at the ones that have easier numbers. I'm going to skip the ones with fractions for now, but I'm going to look at this one here. Y is 8, X is 1. 8 over 1 is 8. And then I'm going to look at the other one. I'm going to skip the fractions for now because they're more complicated. And look at that other one. 16 over 2 is 8. So they have the same unit rate because they both simplify to simply 8. So is it proportional? Yes. And it's because they both had that unit rate of 8. Our other option is to cross multiply. And I'm going to use these same two ratios to make it a little easier. But if I have 8 over 1, is that the same as saying 16 over 2? And so if I cross multiply, I can do 8 times 2, 8 times 2, and I can ask myself, does that equal the multiplication of my other diagonal? Does that equal, that's what I'm asking, 16 times 1? Well, 8 times 2 is 16. 16 times 1 is 16. And yes, they are equal. And so because they're equal, yes, we just proved these are proportional. You can use any of these options. Now, just to note, if we would have done these fraction ones, it would be the same. 4 over 0.5. Well, if I'm trying to figure out what would that be over 1, half times 2 is 1. 4 times 2 is 8. It's still equal to 8, just like we had down here. And the same would happen here. 12 over 1.5, when we divide, it still also equals 8. So every single ratio that we looked at was the same. So now we have two options. We know we can use check to see, do they have the same unit rate? Remember, we like to do y divided by x if we have an options. Or we can cross multiply, where if we have a over b, does that equal c over d? And we multiply those diagonals. So knowing we have these two options to pick from, we have two more problems to complete. The first example says, are 4/5 and 80/100ths proportional? So I have 4 over 5 and 80 over 100. So one option is to reduce. So do they make the same ratio? And our second option is to cross multiply. So if I cross multiply, I have 4 times 100. Is that equal to 5 times 80? And when I multiply, 4 times 100 is 400. 5 times 80 is 400. Yes, they are equal. So yes, these two ratios are proportional. Our next problem, example 3, asks if 3/4 and 15/20 is proportional. So one option, if we look at those equivalent unit rates, I could go ahead and try to reduce 15/20. Well, I know they both divide by 5, and it reduces down to 3/4. 3/4 is the same as 3/4, so yes, they are proportional. But you could also always cross multiply if you would prefer. Is 3 times 20 the same as 15 times 4? 3 times 20 is 60, 15 times 4 is 60. Yes, they are equal, so yes, they are proportional. No matter if you're using unit rates by simplifying like we did here, or if you're cross multiplying, we should always be able to prove whether they're proportional or not. We can use this idea of proportionality to solve problems. So this first problem reads, a boat can travel 396 miles on 132 gallons of gas. How far can it travel on 84 gallons? So when we're setting up proportions like this, given in word problem context, we need to make sure we're watching the labels. The first proportion that I highlighted in orange is 396 miles over 132 gallons. I need to set up this proportion, which remember is a fraction equaling a fraction, with 84 gallons, how far can it travel? So I want to look at my labels. If I have gallons I put on the bottom. So my 84 is going to go on the bottom of my other proportion. 84 gallons. And I need to figure out how many miles can that travel. When I have a problem like this, it's going to be easiest to cross multiply. When I cross multiply, I have 396 times 84 equals 132 times x. So now we have to go back to using our solving skills, and we can go ahead and solve for x. When I multiply, I get 396 times 84 is 33,264 equals 132 times x. To solve for x, remember we have to undo the multiplying, so I'm going to divide by the number in front of my x, so I'm dividing by 132. And when I divide by 132, x equals 252. So that means, how far can I travel? I can go 252 miles. We want to make sure that with word problems, we write our answers in a sentence and that the number 252 has a label to go with. In this case, it was miles. And then last but not least, we have simply a proportion to solve. So, complete the proportion. We're going to cross multiply. If you want, you would also look at the relationship. So if you cross multiply, you would have 28 times 14 equals 2 times x. And we can solve for x just like we did in that previous problem. But also, I notice to go from 2 to 14, I multiply by 7. So I could also use that idea to solve for x. So in this blue, I could do 28 times 7 to figure out this top number is 196. Or I could go ahead and continue to solve that proportion. 28 times 14 is 392 equals 2 times x. Divide by 2 on both sides. And when I divide by 2, using this method, I still end up with x equals 196. So no matter which way I solve for x, whether it's finding that relationship or cross multiplying, you get the same answer either way. And you can use whatever method works best for you.